The day in class that we did day 2 of our factoring notes, at the end I gave everyone 6 mixed review problems, and depending on the class and the time we had, some of you got to try it on your own, some of you had to do it independently, but this is the video that goes along and explains those 6 problems, and I'm kind of going to do them in a random order, kind of increasing difficulty as we go through here. So on the first one, because this starts with a negative, that's a giant red flag that you've got to take out a negative greatest common factor. So on this one, the biggest number I take out is -5. Now I'm not taking out any variables, so my variables remain the same. So I have x squared, 80 divided by -5 is -16. So in the parentheses, I have a binomial. So with a binomial, I can either do squares or I can do cubes. Those are my 2 choices. Okay, well, inside this parentheses, since I can take the square root of everything, I want to do the square pattern. It doesn't fit the cube pattern, so my GCF gets carried down. And then with the square pattern, I go straight to my 2 parentheses. The square root of x squared is x, the square root of 16 is 4, and 1's plus, 1's minus. That can't factor further because the the exponents of the variables are that invisible 1. All right, let's see what happens on number 2. Number 2, I'm going to look for a greatest common factor. There is not a greatest common factor, so I'm just going to start factoring. It's a trinomial. Okay, with a trinomial, the leading coefficient can be 1, which is the green light, or the leading coefficient can be not 1, and I'll split the middle term. Okay, well this one is not 1, so I'm going to split the middle term. Excuse me, I totally said that wrong. This one, the leading coefficient, is that invisible 1, so it's a green light. I'm going to go straight to my 2 parentheses. Normally, I'd put an x and an x, but an x and an x would multiply to x squared. I need it to multiply to x to the 4th, so I'm going to put x squared and x squared. That will be the only thing you change in the problem. Now I'm looking for 2 numbers that multiply to -27 and add to -6. Those numbers would be -9 and +3. Because these exponents right here are something other than the invisible 1, I have to check to see if it factors further. Well, it's a binomial, so it could either be squares or cubes. Cubes doesn't make sense with the exponent of 2, so squares makes the most sense. The x squared plus 3 does not factor further, but this one does. This one is going to factor to x plus 3, x minus 3, because it's the difference of squares. And this one is going to remain the same, x squared plus 3. And there we go. All right, now we're going to go down to number 4. We're just going to kind of skip around a little bit. Number 4. First thing we need to look for, every single time you start a factoring problem, you're going to look for the greatest common factor. And the greatest common factor in this one is 2. So I'm going to take out a 2. I'm not taking out a variable. It's not going to change my variables. So this gives me x squared plus 3x minus 88. Inside, I've got a trinomial. So trinomial, it's either a green light or split the middle term. Well, the leading coefficient right here is this invisible 1, so it's a green light. That means I'm going to go straight to my 2 parentheses. I'm going to have an x and an x. Now I need 2 numbers that multiply to -8 and add to, -88 and multiply to +3. So that would be +11 and -8. That's my answer. Okay, let's take a look at number 6. On number 6, first thing we look for every single time is the greatest common factor. There's no number I can divide by both of these, but I can take out an x, so I'm going to take out an x. So since I'm only taking out a variable, it's only going to change the variables. The numbers will stay the exact same. So I have 27, I have 4 x's, I take away 1, and I have x to the 3rd, minus 64, those x's cancel, and I have y to the 9th. Now I need to see what pattern am I going to use. Well, it's a binomial. So if I look with a binomial, I can do square or cubes. Squares work when the exponents are even. Cubes work when the exponents are divisible by 3. Well, this one, it's a cube pattern. Okay, and then I can take the cube root of all those numbers. So my greatest common factor gets a free ride. The cube root of 27x cubed is 3x, minus the cube root of 64 is 4, and the cube root of y to the 9th is y to the 3rd. I knew that because 9 divided by 3 was 3. So now, to get the second parentheses, I follow the pattern. I take the 3x and square it, which would give me 9x squared. Change the sign to a plus. Multiply the two things together, which would give me 12xy cubed. The last sign is always plus, and then I have to take 4y cubed and square it. So that's going to give me 8. Y cubed squared is power to a power, so I'm going to do 3 times 2, which is 6. So it's y to the 6th. And that is my final answer. Okay, let's take a look at number 5. So on number 5, I need to start by looking for greatest common factor. And because this starts with a negative, this one is a huge red flag. There has to be a greatest common factor. And that greatest common factor on this one is going to be negative 3x. So I take out a negative 3x. 18 divided by 3 is 6. And then I'm going to get 6x squared. 21 divided by negative 3 is negative 7x. And then 60 divided by negative 3 is negative 20. If I look inside the parentheses right here, it's a trinomial, and the leading coefficient is not 1. So a trinomial is I can either do green light or split the middle term. If the leading coefficient is not 1, I've got to split the middle term. So to do that, I'm going to take 6 times negative 20, which is 120. Now I need two numbers that multiply to 120 and add to negative 7. Okay, well, I could try a bunch of things, but I'll just tell you those two numbers are going to be negative 15 and 8. So what do? The greatest common factor gets a free ride. That's negative 3x. 6x squared stays the same. The one in the middle gets split to negative 15x and 8x minus 20. Okay? Again, recopy the greatest common factor. What can I factor out of the first two terms? 3x. That leaves me with 2x minus 5. Sign in the middle comes straight down. What can I factor out of the next two terms? 4. And that leaves me with 2x minus 5. Now how do I write my final answer? Greatest common factor. Keep copying it. The next parentheses is the one they both share, which would be 2x minus 5. Then we're going to make a parentheses of what gets split, 3x plus 4. And that's going to go here, 3x plus 4. All right, we've got one problem left, okay? And it's a little bit challenging only because it factors two different ways, but it reviews a bunch of stuff. So first thing we need to look for is a greatest common factor. There isn't one. It's a trinomial, so with the trinomial we can either do green light or split the middle term. The leading coefficient is not 1, so we're going to split the middle term. So 2 times negative 24 is going to give me negative 48. The two numbers that multiply to negative 48 and add to positive 13 would be 16 and negative 3. So I'm going to rewrite this as 2m to the 6th plus, now I'm going to split this. Now normally I just do 16m, but it's got to match that. So I can't do m, I have to do 16m cubed minus 3m cubed minus 24. Now I'm going to factor by grouping. Out of the first two, I can take out 2m cubed. That leaves me with m cubed plus 8. Whatever the sign is in the middle, I'm going to copy it straight down. So I'm going to take out a minus. Out of the next two, I can take out a 3. But it's really a negative 3, which is going to change the sign, so I'm going to get m cubed plus 8. Now I need to rewrite it. So what they share is the m cubed plus 8. And then what they split was the 2m cubed minus 3. Now it looks like we should be done, but when the exponents are not the invisible 1, we have to see if it factors further. Well, when it's a binomial, you can either do squares or cubes. Well, the exponent of 3 really just works for cubes. Now if I look at this one in the green, I can't take the cube root of 2 or 3. But oh my gosh, 8 is on my cube list. So that means this first one is going to split because it's going to factor, and it's going to factor by the sum of cubes pattern. Okay, so the sum of cubes pattern, that's like what we did on number 6. The cube root of m cubed is m, plus the cube root of 8 is 2. Use my pattern now. Square the m, change the sign, multiply the two things together, square the 2. But this one can't factor further, so I just recopy it. Oops. And this whole big thing is my final answer. Now remember, if you would like more help, you can also come to the review session on Wednesday the 9th between 1 and 2:30 during my office hours.